We're back. We're here to find the surface area of prisms and cylinders. And to do that, we have to find the area of all the sides. And a prism is a polyhedron that has two faces called bases that lie in parallel planes. So the bottom down here of this is in the same plane as this one down here. Then it is a prism. So we call those our bases. And to do that, one way is to unfold the whole shape like this net down here. We take a rectangular prism, unfold it, and then you could simply find the area of that and add two of these to it, and you'd have the area of the surface area. The other way is to use a formula for it, which is twice the base plus the perimeter times the height. And the perimeter times the height, if we go back to that, this would be the perimeter right here, which is the distance around this thing, unfolded, times the height. So that's one way to do it. And let's go back and look at this example problem. So twice the base, that's adding the two bases, times the perimeter times the height, which will give you that net unfolded. If I was to unfold it, I'd have another rectangle here, and this back one coming around here would give me another rectangle here. So there's my perimeter times the height. And then the bottom and the top, which is twice the bases. So let's look at this example over here. Find the surface area of a rectangular prism with a height of 3 centimeters and a length of 6 centimeters and a width of 8. So I'm going to call this the base down here. I'm going to do twice the base, and that's going to be base times height, right? Lowercase base. And the perimeter is going to be 8 plus 6 plus 8 plus 6, which gives me 28, times a height of 3. So here I go, 2 times base, which would be 6 times 8. That's the area of the bottom of that thing. Plus 28 times 3, that looks like 60, and 24 is 84. 12 times that gives me 80, 96, plus 84 gives me 180. And do we have units for this? Well, it's centimeters times centimeters, and centimeters times centimeters, which gives us centimeters squared. Twice the base plus the perimeter times the height, which is that net if we unfold that object. Slightly trickier problem because the bases are this hexagon on top here. And if you remember, there's 1, 2, 3, 4, 5, 6 angles, which makes each of these angles 60 degrees, which makes this 60 degrees. So what we end up with, if we come down here, is an equilateral triangle, right? And equilateral triangles, if we cut them in half, gives us a 30, 60, 90 triangle. And we know this is 6 points. So if we call this 1, this is going to be 2, and this is going to be radical 3, or 1 times A, 2 times A, and A times radical 3. So we know this is 6.4 along the bottom because they told us the radius is 12.8. So we divide that by 2 to get that because it's twice as long. And the height is going to be 6.4 times radical 3. And we get an answer for that by asking our efficient TA, Mr. Corey. 11.09 he comes up with, and that is measured in feet. So there's our, so to find the area of this triangle, or the area of the prism, or the area of the hexagon, we're going to have 6 times the area of the triangle. And 6 times 1/2 base times height gives us 6 times 1/2 times a base is 12.8. Our base is right here, and now we need that height. We have that in the drawing. We just calculate it. It's 11.09. 11.09, giving us a area of the hexagon of, and Corey comes up with 425.86, he said? 856, and that's measured in feet, and it's feet times feet, so feet squared. So that gives you the area of the hexagon. Now let's go back and find our surface area. We have 2 of the bases, which is 2 hexagons, so 2 times 425.856 plus the perimeter.